the proton was discovered by the Goldstein, and the electron was discovered by the J.J. Thomson, and the neutron was discovered by the Chadwick. Space in an atom was empty. That is why the particles are moving in a straight line. When the electrons are revolving around its own orbitals, it will exhibit the electromagnetic radiation. Atomic number means number of protons present in the nucleus of an atom, which is also equal to the atomic number. Hello my dear students, a warm welcome you all. Myself is Podima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called Structure of Atom. Under that, we have understood about the introductory part of this unit about the atom, and also we learned about the discovery of subatomic particles, which means to say that the discovery of the electron, the discovery of the proton, and the discovery of the neutron. We learned that the proton was discovered by the Goldstein, and the electron was discovered by the J.J. Thomson, and the neutron was discovered by the Chadwick. Isn't it? All these three scientists, how does they discover the proton, neutron and electron, we have understood. Today, let us move on to the next topic of this unit about the atomic models, which was proposed by the different scientists. The first one is Thomson model of an atom and Rutherford model of an atom. So these two which comes under the atomic model. In addition to this, we are also going to discuss with the atomic number, mass number and isotopes and the isobars. So firstly, I'll go with the Thomson model of an atom. So remember, the atomic models was first idea was given by the J.J. Thomson, later was given by the Rutherford. Okay, let us see how does he explain the structure of the atom in his own way. Let us understand now. So J.J. Thomson in 1892, he proposed an atom possesses a spherical shape. In 1898, the J.J. Thomson was the first scientist. He proposed the structure of atom. Okay, what does he explain? In which the positive charges are uniformly distributed and electrons are embedded on it. According to the J.J. Thomson, he says that the atom will possess a spherical shape. Okay, in which the positive charges are equally distributed. It is equally distributed, whereas electrons, that is the negatively charged ions, which is embedded on it, which means to say that which is present on the positively charged sphere. So this was an idea about the structure of an atom was first given by J.J. Thomson. And for this model, we can have a many names, and it is also known as Plumpkin pudding model or resin pudding model and watermelon model. So this model can be known as a model of watermelon. Why it is known as a model of watermelon? Because he explained that the atom will have a spherical shape. So if you cut the watermelon, and you can see that the fleshy part will be having spherical in shape, where the positively charged spheres can be seen. Is it right? The red color, which is known as positive charges, where the electron, which are nothing but the seeds of the watermelon, which is embedded on it, which is just present on the positive sphere. So like this, he compared the model of an atom with the structure of watermelon. Hence this model, which is also known as watermelon model. Okay, or pumpkin pudding model. And according to him, he says that important features of this model is the mass of an atom will be uniformly distributed over the atom. He says that Within this positive spheres, the negatively charged ions are embedded where the positive charges are equally numbered. So this was a idea about the structure of the atom. Why this atomic model which is get failure? Because this model was able to explain over the neutrality of an atom but not consist with the results of later experiment. Only it will explain the neutrality of the atom. So after that, it will not explain. So when the atom which consists of the neutral number of protons and the neutron, that was explained by the J.J. Thomson. Suppose if the atom, whether it loses the proton or if it gains the electron, that was not actually explained by the J.J. Thomson. Hence this atomic model was failure. Understood? Next we'll see the Rutherford model of an atom. Let's see how the Rutherford, he explained the structure of the atom in his own way. Rutherford, the alpha scattering experiment, a stream of high energy alpha particle of a radioactive sources was directed at a thin foil of gold metal. Here, to explain the structure of an atom, Rutherford consists of alpha particle. So, which is radioactive sources where the alpha particles are present, which is allowed to fall on the thin gold foil. What does he make? He prepared the alpha particle in the radioactive sources and made to fall on the thin foil of the gold foil. What will happen? Thin gold foil had a circular fluorescent and a zinc sulfide screen around it. In addition to this gold foil, you can see that the circular fluorescent material which is present. Why he has put that circular fluorescent material? Just to know that the behavior of the alpha particle. How does it behave when it is able to bombard on the gold foil? When you pass the alpha particles on the gold foil, how does it behave? In order to understand one, he put that circular fluorescent material. Okay. Whenever the alpha particles struck into the screen, the thin flash of light was produced at this point. When alpha particles which is allowed to fall on this thin gold foil, so this thin gold foil, it will absorb that alpha particles and produces a tiny flashes. In order to know that, he set up this experiment. Hope you all understood with the experiment. Now let us see what is the result of this experiment. So what will happen when you passes the alpha particle? This is a alpha particle, okay, which is allowed to fall on the thin gold foil. This is a thin gold foil. And around this, he put the fluorescent material just to observe the behavior of this alpha particle. What does he observe? At firstly, he observed that most of these alpha particles are moving in a straight line. All these alpha particles, when you hit the thin gold foil, almost all these alpha particles are moving in a straight line. This was a first observation. And secondly, he observed that few alpha particles are deflected in some angle. Few of the alpha particles are deflected. They are deflected. And thirdly, he observed that few alpha particles are deflected back. So when he passes the alpha particles to bombard on the gold foil, few alpha particles are rebounded back. It comes back. So this three observation was first made by the Rutherford while doing the alpha scattering experiment. Understood? What does he observe? He observed that few alpha particles are moving in a straight line and few alpha particles are deflected and few alpha particles are rebounded back. Why does rebounded back? Why few alpha particles are deflected? Why most of the alpha particles are moving in a straight line? That was explained later. Okay, this is a gold atom which is present in the gold foil, where you can see that alpha particles are moving in a straight line, where few alpha particles are deflected and few alpha particles are rebounded back. Okay. Why it is so? He explained this by giving some of the conclusion. Let's see what is the conclusion for this. Okay. Most of the space in the atom was empty. Suppose, imagine this is an atom. We know that at the center, nucleus will be there. Is it right? That is why when you pass the alpha particles, most of these alpha particles are moving in a straight line. Is it right? This is the reason. That is why the particles are moving in a straight line. What is the reason? Because most of the space in an atom was empty. That is why the particles are moving in a straight line. Second one, the positively charged is concentrated in a very small volume and that repelled, deflected and few alpha particles, and this a small portion of the atom which is known as nucleus. Why few alpha particles are deflected? Because he explained that at the center we have a positively charged ions. They are known as a proton, which is present in a small volume at the center. That is why when these alpha particles, when they stuck, it will get deflected. It will get deflected. Understood? For the third one, he says that the volume of the nucleus is very small as compared to that of the volume of the atom. He says that why few alpha particles are rebounded back? Because when this alpha particles goes and hit to that nucleus directly, it will come back. So why it is coming back? Because the volume of this nucleus, which is always smaller than that of the atom. That is why when it is hit, it is coming back. This was a three conclusion was given by the Rutherford to explain the Rutherford model of an atom. Understood? What was the first conclusion? Why alpha particles are moving in a straight line? Because most of the space in an atom was empty. That is why most of the alpha particles are moving in a straight line. Why few alpha particles are deflected? Because when they coming in contact with the volume of the nucleus, it will get deflected. Suppose imagine you're walking on the road. Suddenly bus comes means what you'll do? You'll change your direction. Like that here, the alpha particles also, when something is there at the middle, it changes direction. It changes direction of the movement. That is why it is get deflected. And also thirdly, he says that the volume of this nucleus is smaller than that of the atom. That is why most of the alpha particles are deflected. If somebody comes and hit you, what you'll do? You will go back. That's it, right? Somebody goes and hit you, you'll fall down. That's it, right? The same thing which has happened here. So here, the alpha particles, when it is hit on the nucleus, which is coming back. So these are the three observation and three conclusion was given by the Rutherford. Next we'll see with the nuclear model of an atom. After observing all these three different things, and he made a conclusion for that. Later, he proposed a model that is known as nuclear model of an atom. Let's see what is the nuclear model of an atom says about the atom. Okay, positive charges and most of the mass of an atom were concentrated at the nucleus. He says that in an atom, there is a positively charged spheres will be there. Okay, that was the first postulate. And nucleus is surrounded by the electron, which are circular orbits at a very high speed. He says that this is a structure of an atom where the nucleus will be present at the center, and this nucleus which are rich in positively charged particle. Okay, and he says that around this nucleus the electrons are revolving in a circular path and also in the orbital motion. And lastly, he says that the electrons and the nucleus are held together by the electrostatic force of attraction. These electrons as well as the nucleus, The force between the electron to the nucleus, they are held together by the force of attraction. This was a conclusion, or we can say it is a nuclear model of an atom was proposed by the Rutherford after doing with the experiment by using alpha particle along with the gold foil. It is quite interesting to learn with the Rutherford model of an atom. Nextly, we will see with what is the drawback about the Rutherford model of an atom. According to the Rutherford model of an atom, electrons are negatively charged particle and it will revolve around the nucleus in a fixed orbital, and these electrons undergo acceleration. He says that at the center always nucleus will be there, and around the nucleus what will be revolves? Electrons are revolving. If the electrons are started revolving, it will goes in a circular path. Finally, it will fall down on the nucleus itself. So actually it makes the matter not to exist, and this will be a biggest disadvantages for the Rutherford model of an atom. And according to the electromagnetic theory of Maxwell, the charged particle undergoing the acceleration should emit the electromagnetic radiation that the electron of an orbit should emit the radiation that the electron should shrink, but it does not happen. When the electrons are revolving around its own orbitals, it will exhibit the electromagnetic radiation. When it expresses the electromagnetic radiation, finally it will shrink and it will fall on to the nucleus. When the electrons are fall on to the nucleus, we know that the matter will not exist. Is it right? This model does not give any information about how the electrons are distributed around the nucleus and what are all the energies of this electron. And this model, this was not explained the actual position of the electron in his model, and it does not explain the energies of this electron. That is why this Rutherford model of an atom, which is also get failure. Only thing is, you just remember that electrons are revolving around the nucleus. So what will happen? Suppose you are revolving around your own self. What you will do? Finally, you will get tired and you will fall down. Like that, when the electrons are started revolving, at a particular point, it loses its energy and it is finally fall onto the nucleus itself. When it is fall onto the nucleus, then the matter will not exist. This was the actual thing. It will become a drawback for the Rutherford. Next, we'll move on to the atomic number. Okay, next the model of an atom we'll study it in the next session, and we'll also move on to the next topic, that is atomic number. What is an atomic number? Atomic number means number of protons present in the nucleus of an atom, which is also equal to the atomic number. So what is an atomic number? Atomic number means number of protons present in the nucleus of an atom, and it is always denoted with the digit called as Z, okay, capital number Z. And number of proton in the nucleus, which is also equal to the number of electron, as we know that. So this is a basic symbol for an element. That is, imagine this is an element, and A represents the mass number and Z will represent the atomic number. What is an atomic number? Number of proton which is present in a nucleus. Remember, it is always equal to the number of electrons also. For example, in the lithium, atomic number is 3. Okay. Whereas for the helium, atomic number is 2. Like this, we will express or we will identify the atomic number. Next, we'll move on to the mass number. What is a mass number? It is nothing but a number of proton plus number of neutron which is present in the nucleus of an atom. So it is the number of proton and number of neutron. So it is said to be mass number. For example, in the aluminium, the atomic number Z is 13 and mass number A is 27. Why it is 27? It includes both the protons and neutron. Clear? And next one is, in case of the carbon, we know that atomic number is 6. And whereas the mass number is 12. Why it is 12? Because it consists of 6 protons and 6 neutron. That is why the mass number will be 12. This is how we can easily represent the atomic number and mass number. Always think that atomic number, imagine this is X, atomic numbers will be usually represented at the base. That is Z, whereas the mass number is A. So the mass number that include both the protons and neutron, whereas the atomic number which include only the number of proton. Okay. Next we'll move on to the isotope. Let us understand what is an isotope and isobars. Okay. The atoms of a same element having same atomic number but a different mass number. Atoms of the same element, okay, they have a same atomic number but different mass number. Here I have taken the example of the hydrogen, which is having the similar atoms. That is, the isotope of the hydrogen is H1, H2 and H3. This is the isotope of a hydrogen atom, where you can see that this is atoms of the same element having same atomic number, but there is a difference in the mass number. Such kind of elements are known as isotopes. Isotopes means the atoms of the same element having same atomic number but different mass number. Here in case of the H1 and 1, here it consists of only one mass number, one atomic number. Whereas in case of this hydrogen 2, when you can see that the mass number is 2, whereas the atomic number is 1. Whereas for the hydrogen 3, the mass number is 3 and the atomic number is 1. And hence it is named as hydrogen, deuterium and tritium. Why does hydrogen 1, deuterium and tritium? Because in the hydrogen 1, which consists of one atomic number and one mass number, here 2 mass number will be there, hence it is deuterium, and 3 mass number will be there, hence it is tritium. This is how isotopes can be defined. Next comes to the isobars. Here it is different. Atoms of the different element having same mass number but different atomic number. For example, in case of the argon and potassium as well as the calcium. In all this case, you can see that the argon which having the 40 atomic number, whereas for the potassium, it is having the 40 mass number, whereas for the calcium, it is having 40 mass number. This shows that all these elements are, even though they are different, they having same mass number, but their atomic number will be different. It is 18, here it is 19 and it is 20. Such kinds of species are known as isobars. Why it is known as isobars? Because these are the atoms of different element having same mass number but different atomic number. Hope you all understood with the isobars and the isotopes. Next comes to the isoelectronic species. What is this isoelectronic? Isoelectronic species are containing same number of electrons. Such species are called as isoelectronic species. Example is O2 minus, F minus, Na plus, Mg plus and aluminium 3 plus. In all these elements, it consists of only 10 electron, hence they are known as isoelectronic species. Why they are known as isoelectronic species? Because they consist of same number of electron. If you consider the sodium, when it has become plus, only when the sodium, the atomic number is 11, when it loses one electron, is it right? It gains the positive charge. Similarly, if you take magnesium, when it loses the 2 electrons, it gains the 2 plus charges. So, in all these elements, which consists of same number of electrons, hence such species are known as isoelectronic species. Next, we'll move on to the numericals. How to do with this? Let's see now. Calculate the number of protons, neutron and electron in 80, 35 bar. In 80, bromine 35. This is a given element. We need to find the number of protons and number of neutron. First, I'll write Z is equal to 35. Is it right? That is our atomic number, and mass number which is equal to 80. We have understood that Z which is equal to number of proton. Is it right? number of proton. So how much it is there? So it is 35. So number of proton in the bromine is 35. And also we have understood that number of proton which is also equal to the number of electron. So that number of proton and number of electron which is equal to 35. Next comes to the number of protons and neutron. How to find the number of proton and neutron? We know that atomic number, that is a mass number, will be Z. Is it right? So the mass number in the sense which consists of number of protons and neutron. Is it right? So number of proton plus number of neutron. Now I know what is the number of proton and number of electron. I need to find out the number of electron. How to find this? I will take out the number of electron outside. Mass number will be 80 minus number of proton, that is 35. How much you will get? 80 minus 35, which will be equal to 45. So this will be a number of neutron. This is how we can easily calculate the number of proton, neutron and electron in a given species. How do I do now? Here, first thing, we need to write the atomic number and the mass number. Atomic number will be equal to the number of proton, which is also equal to the number of electron. So Z is equal to 35. Now I know the values of the A, that is the mass number, and the number of proton also I know that. I need to know the number of neutron. How to do with this? The mass number minus the number of proton. So which is equal to 45. 45 is the number of proton. Okay. Sorry, 45 is the number of neutron. Next, the number of electron, protons and the neutron in a species is equal to 18 and 16 and 16 respectively. Assign the proper symbol of the species. So here they have given the electron, proton and the neutron. Electron will be 18, proton will be 16 and the neutron will be 16. Assign the proper symbol of the species. Now I'll write Z, which is equal to number of proton, that is the atomic number. So atomic number means number of proton, which is also equal to the number of electron. How many number of proton will be there here? It is 16. And now you can take the A, that is the mass number, which is equal to the number of proton plus number of neutron. Number of proton plus number of neutron. So it is 16 plus 16. So it has become 32. 16 plus 16, it will become 32. But we have understood that number of the proton should be equal to the number of electron, as we have learned in case of the atomic number. But here the number of proton is 16, but number of electron it is 18. How does? So the molecule which is not a species which do not have a neutral number of protons and neutron, it should having a excess of electron. So how to find that structure? Now we have understood that the atomic number 16 in the sense it is sulfur. Is it right? So it is 16. And mass number, that is 32. We can write directly. But here the sulfur do not have a same number of protons and the electron, because as we found out the number of proton is 16, but the given number of electron it is 18. Show that the species or the atom or the element should have an excess of electron. So how to know this excess of electron? Simply by subtracting the number of electron minus number of proton. So that number of electron minus number of proton, if you minus these two, it is 18 minus 16, you will get 2. So you will get 2. So it is 2 minus. So this is how we can easily assign the element symbol also by using the given data. In this numerical, just observe, they have given the number of proton, neutron and electron. Here the proton and electrons are not equal. That is why I have written only Z as 16. Later I found out that the mass number which is equal to the number of proton and electron, it is 32. We know that the element which is having a 16 atomic number, it is sulfur. And it is having the mass number 32. But it is having the excess of electron. Why it is having excess of electron? Because it accepts the 2 electron. So that is why it is 2 minus. This is how we can easily assign the elements name by understanding the data. Hope you all understood with these two numericals. In the next session, we are going to deal with the developments lead to the Bohr model of an atom. Let's see what all the developments. And finally, I'll wind up here. We will meet you in the next session. Till that, take care. Thank you.